Hey folks, welcome. It's me, Neil, by the way, running the thing. I guess actually the other person who came here, Jayla Cobbs, has taken off. Otherwise, M.E. What's your full name? If you might want to type that in the chat window. I just want taking attendance today. That's all I care about. But being able to call on you by your first name would be kind of cool as well. All right. Lindsay, I got you, but then also underneath there's somebody else called M.E. who I haven't heard from. But Lindsay, good to see you. I see your first name in the panelist window. Welcome, welcome. I'll be probably starting to chat a lot more in about 3 to 5 minutes. So otherwise I'm going to stay on mute. All right, folks, welcome. Hi, I'm Neil. Welcome to the free GRE Prep Hour. Let's talk about what this prep hour is and what it is not. What this prep hour is an opportunity for us teachers to sort of nerd out on the GRE in some way or another. I'm going to get that window out of the way and slightly brighter light. So it's just an opportunity to really deep dive on one aspect of the GRE and talk a little bit about prep overall by kind of focusing on one particular subject is what that allows us to do. What this is not is an overview of the GRE overall. If you would like an overview of the GRE overall, what I highly suggest you do is sign up to class 1 of any of our online classes or any of our in-person classes. All of our class 1s are always a free trial class, and that will give you a great overview on the GRE, overview on how to prepare for the GRE, what is on it, what's not on it, how various sections and various scoring works from there. So those basic questions can be answered there. Today, our agenda is as follows. So somebody mentioned this already. I do want to, let me do some deleting of things and we will move on to the next page. All right, so the source of all of our questions today comes from the Manhattan Prep book, the 5-pound book of practice problems. Just to let you know, this is available on Amazon, as are all of our other things. Our agenda for today is I'm going to deep dive a little bit on geometry, circles in particular, right triangles from there, and how those two concepts might be combined on really, really quote unquote difficult GRE problems, where if you know basic things about circles and basic things about right triangles as they're tested on the GRE, then you can get some really tough problems done. What this should be as far as the overall GRE experience is, look, if I deep dive on one thing, if I really memorize how this particular thing works, say whether it's circles or standard deviation, or whether it's particular question type on verbal, like what we call inference questions on verbal. If I understand that thoroughly, I can apply those skills to other areas. And also it shows you how a little bit of memorization on the part of the GRE can help you save tremendous time on questions that will take other people 5 minutes, you're knocking out in 20 seconds because you understand certain patterns that are tested on the GRE. So that's what we're up to today, and that's why we're up to it. And also, I just think geometry is kind of fun and cool to work with. So let's go and let's chat a little bit about circles. What are some of the keywords that pop up when circles come into play? Like if you see a circle on the GRE, what are some of the questions you have about that circle? What are some of the things they might ask you about a circle? Excellent. All right, so we've begun already. So we have the circumference. What are some other things that pop up? All right, the perimeter, also known as the circumference, by the way. So the circumference is the perimeter. Also, yeah, all right, so we have the radius of the circle, we have the diameter of the circle, and then also the area of the circle. So what we're going to call that today is, look, when a circle pops up on the screen on GRE, or when it pops up in a GRE book, the first thing I'm always going to write down when it comes to I see a circle, the first thing I'm going to write down is RDCA. So that's the first thing you're going to memorize today. So when a circle shows up, you type in RDCA. So when a circle shows up, you write down RDCA. So everyone type in the letters RDCA and hit enter. You'll see why I'm doing this in a minute. There you go. So radical RDCA. So this is what is in a circle. And these are the things we're going to need to know about a circle. So if a circle shows up on the GRE, I'm going to write down RDCA and it's going to look like this. Let's talk about how these things work together. And then we're going to learn to memorize things to make this stuff move super lightning fast. First of all, the radius. I always think about it like a spoke on a bicycle wheel from the center to the edge. So that's the radius. How do I get from the radius to the diameter? What do I do to the radius to get how long the diameter is? So this diameter looks, so this radius, I don't know, let's say that's about 2 inches long there. All right, so what do I do to the radius to get to the diameter? Multiply it by 2, sweet. So whatever the radius is, we'll call R. The diameter is just twice as long. So in this case, if the radius is 2, the diameter is 4. So the diameter goes from the edge through the middle out to the other side. So there's my diameter, which is twice as long as the radius. Sweet, excellent. Circumference. What did we say the circumference is also known as? Perimeter. All right. So what we're talking is the distance around, the length around the circle. So if I go, so how far, oops, sorry, let me back up. So how far around a circle we're talking here is, all right, new tools here. So how far around a circle are we going? That's our circumference, also known as the circle fence. Like if I laid this fence out, if I stretched it out, how long would it be? Well, what Pythagoras, some Greek mathematician, figured out is if I take this diameter and I multiply it by the magic number, what's the magic number? 3.142, also known as pi. For today, all you guys can short it to P. You don't have to type in pi. You just type, you know, it's the symbol pi on the GRE, or you can write pi that way. So what mathematicians figure it out is if I want to figure out how long this circle fence is, how long this distance is around this circle, how long that fence is, how long that line is, the distance around, all I need to do is take that diameter and I multiply that by pi. So diameter pi times pi, or yeah, or pi d. Now you may remember, and your math teachers might have taught you 2 pi r, and I want you to get that out of your head and remember it as pi times the diameter. So so for the circumference, we're going to go 4 pi. This is just to make things a little easier and a little different. We're going to learn things in a different way to make things faster and better. All right, cool. So that is how we got our circle fence. All right, area. Here's a question for you about area. When I walk into Home Depot and I need to paint my floors or I need to wallpaper my room, what do they ask you? Say, I need to paint my floor. I need flooring for my formula. They ask me how many what? Square feet. All right, or square meters here in New Zealand, or square inches, depending on what you're paving. So if I take 2 and I square it, say that radius of 2 and I square it, yeah, you got it, Kiptara. So yeah, we got it. But I just want to talk about what area actually means for us before we move into how do we think about it. All right. So if I take a look at this area, I have 2 inches this way by 2 inches this way. Notice what I end up with is 1, 2, 3, 4 square inches, right? So if I think about area, I'm thinking about how many squares I have. So if I think about this as taking that radius and squaring it, well, so I take that radius and I square it and I multiply that by 3.14, I get my area. So the radius squared times 3.14. So if I have 3.14-ish of these squares, I will get how many square inches are in this circle, which is, again, coincidentally, 4 pi square inches. All right. Thinking about length as pieces of string and thinking about areas as squares can begin to help me make fewer cognitive mistakes as I'm working through this. So we see a circle. What do we write down? RDCA, excellent. All right, there we go. You see a circle, you write down RDCA. So let's start slamming through this and start getting through this super quick. All right, so what we can start doing is, do me a favor, make a little RDCA chart. So on your scratch paper, write RDCA, and then work your way over from there, whichever way you go on your screen. All right, so you start here and you work your way over RDCA. So I'm gonna start working through this. So this is a circle, and I'm telling you the radius of that circle is 3. So again, P equals pi for you all typing in the chat window today. So let's start playing around and let's start making this work for us. So if the radius is 3, what is the diameter? 6. Diameter is just 6, all right? What is the circumference? Multiply by pi and you get 6 pi, great. And that's the way it'll show up in the GRE, cool. So square that radius and multiply by pi, what do you get? Cool, 9 pi, excellent. All right, so 3, 6, 6 pi, 9 pi. All right, so as we start thinking about this as a pattern, the diameter of the circumference is 6 to 6 pi, the radius to the area is 3 to 9 pi, I can start slamming through these kind of questions pretty quickly. So if the diameter is 8, what's the radius? What's the radius? All right, cool. So just half as much, 4. What's the circumference? All right, cool, 8 pi. So 8 to 8 pi. Now what's the area? Yeah, it'll pretty much always, that's a great question, Amy. Will pi appear as a symbol and not 3.14? Yes. Yes, it'll show us up as a symbol. There's a few times where you want to estimate, and I'll show you maybe an example of that, but yes, it'll show up as, and also thinking about it as a little more than 3. So thanks for that question. Great question, yay. All right, but it'll always show up as pi for the most part, 99% of the time. All right, so I can start, as I said, if I'm given a piece of information, I write RDCA, put it in the right place, and then bam, 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 bam. Just want to be careful. The diameter of the circumference should match. 6, 6 pi, 8, 8 pi. The radius, right? We're not, you know, so I can keep everything separate and keep the pattern going. I'll just do one real quick. Circumference is 18 pi, diameter is 18, radius is half as much as 9, area square that, I get 81 pi. Cool. All right, so if the area is 121 pi, what's the radius? 11, diameter 22, sweet, circumference 22 pi, great. Circumference is pi, what's the diameter? Yeah, okay, so if I think about pi d equals pi, right? All right, so diameter is pi over pi, which is also known as 1. Yeah, all right. What do you multiply by something to keep it the same? 1. All right, so what's the radius? All right, is half as much. Cool. What's your area? Square that radius, right? So if I square zero point 0.5, what do I get? All right, so I get 0.25 pi. Well, more likely on the GRE, I'll get 1/4 pi, or more likely, I will get pi divided by 4. All right, all good? Smiley faces? Making sense? Notice there's tons of mistakes. There's lots of little cognitive glitches through there that happens. Don't be afraid of mistakes, but I want to note where they're happening. Are you confusing doubling something with squaring something? That's happening all the time. I saw somebody go from 0.5 to 1. We want to separate times 2 from squared. Like, so 3 times 2 equals 6. 3 squared equals 9. Those are two different things. Yeah, so 0.25 pi or pi over 4, those are the same thing. 0.25 pi or pi over 4, exactly the same. But again, I mean, generally you'll see GRE phrasing as pi over 4, which is the same as 1/4 pi, right? So it's just, yeah, setting things up that way. So what we're doing is we're realizing once we get the pattern locked, square root of, all right, we can start playing with all the variants. Now, all this is maybe here, this is like a 500 level GRE problem. This up here is like a 650 level GRE problem. This back here will be like a 600. So 1 squared times pi is pi, so that'll be 1, that'll be 2, that'll be 2 pi, and that's pretty straightforward. Now, if I want to start, oh, not sorry, 650. Sorry, that was like a 165 level one. All right. Now, if I want a 169 level or 170 level one, what's missing off that circumference that you would expect to see on this last one? Yeah, pi is not there. So if I think about this and start messing around with this, I want to start knowing the pattern, but then, all right, everyone give me, okay, so if the circumference is 2 pi, these levels are score levels. So the GRE goes from 130 to 170 level, and I'm just trying to give you a sense of like where these questions would appear at what level. Smiley face, does it make sense? So if I say 169, that's a really hard problem. If I say 150, that's a pretty medium level problem. All right, so just to show you how it's the same damn principle, but they're messing with you in ways that are like cognitively difficult to process to make the question a little bit harder. Same damn pattern, same crap over and over and over again, but more layers of weirdness, that makes it a more difficult problem. Okay, where are we? So look to the column to the left. We got 2 and then 2 times pi. But if the circumference is just plain old 2, what do you think the diameter is? Very good, Monica. Excellent. I'll show how folks get there. If I think pi times the diameter is 2, then the diameter is going to be, let's solve that, divide both sides by pi, 2 divided by pi. Excellent. So we got 2 divided by pi. What's half as much as that? What do you think the radius would be? Oh, nice. Okay, so 1 divided by pi. Great. So just exercising the principle, 2 times pi, 2 divided by pi. Okay, all right. Tough, not easy, but definitely doable if we know our patterns. Excellent. Now, area being pi r squared. You know pi r squared. Let's slot that in there. So we got pi times 1 over pi, all of that squared to get my area. So I'm working down at the bottom of the screen. So area is pi times that radius squared. Okay. So let's deal with, please excuse my dear Aunt Sally. Let's deal with those parentheses and those exponents first. What's 1 squared? 1. So pi squared, if I square the bottom, that'll be pi squared. All right, so I just dealt with that bottom part. So I got pi times 1 over pi squared. Great. Now I get pi over pi squared. Do some simplification. I got 1 over pi for my area. All right, so all your algebraic manipulation, all your exponent manipulation, all your please excuse my dear Aunt Sally rule, all of those are going to play to work out something that's a pretty straightforward pattern. So I square 1 over pi, I get 1 over pi squared. I multiply that by pi, I will get 1 over pi ultimately in the long run. All right. Smiley faces, what I would recommend is, anybody a little eked out by what just happened there? You're allowed. It's free GRE prep hour number 1 for a lot of you. Go eek if you're a little eked out by what just happened there. It's okay if you're not a little bit of eek. Okay, this is one that I did like 19 times. I tried, it's all doable, but this is something where I would write down RDCA and play around with what different happens. What if I put a whole number of 4 here? What's the square root of 4 is 2 divided by pi, right? So how do I work that out? And once I've got this pattern of RDCA, and let me show you at its easiest level, try this one on your own. The circumference is 20 pi. I'm going to mute myself for just a second. Write down RDCA, put 20 pi next to the circumference and see how well you do. All right, I'm going to mute myself on this question. What's the area of the circle with 20 pi? We're just trying the same thing, just an easy variation. Go for it. See what you can do. All right, other folks, type in what you ended up with. All right, beautiful, excellent. All right, so what's the area of the circle with circumference 20 pi? Let's go through it and see what we got. And you might have made a mistake, but mistakes are a huge part of it, so no big deal there. So I write down, I see a circle, I write RDCA, I say circumference is 20 pi. All right, cool, that means the diameter is 20, means the radius is 10, the area is 10 squared, also known as 100 pi, and bingo bango. All right, so this is like, now what's funny is this was like a 4-minute problem for a lot of people. So thanks for once we get the pattern locked, bam, 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 right? Well, the one I just did is funny because there's no pi in the funny place here, right? So once you get used to this pattern, if you can do this 2 times, you can start playing with really weird ones like 3 over pi, and that'll be 3 over pi 2, and then you square it and you lose a pi. There's lots of fun variations on this, but once you get used to the variations, 1 gives you tough time, you do it 5 times until it's not tough anymore. And then, yeah, and then it'll all clear up over time. All right, so I'm going to clear off this page for us. Do this on your own, and let's get to, yeah, well, fun for me. I love this stuff, man. So I'm going to let's actually get into some real GRE questions here. All right, so circle has an area of 16 pi. What is its circumference? So we've done this multiple times. Well, let's rock this out together. RDCA, and I just got to make sure I put 16 pi not on the circumference, but on the area this time. So I'm just cautious because I will largely remember the last word I saw, put the wrong thing in the wrong place. So area is 16 pi, now I'm straight up, I'm ready to go. All right, so what's the radius? Cool is 4, diameter is 8, circumference is 8 pi, circumference is 8 pi, all right. Then let's see how well we did. We fought on that one where the circumference was 2. Let's see how we do if now the circumference is 16. We're going to try it again. Minor variation on that really, really difficult one that was all the way to the right. Cool. All right, so the diameter, circumference is 16. What's the diameter? There we go. We got to do 16 divided by pi. Excellent. So what's half of that? Cool. So 8 divided by pi. Well done. All right. So notice the first time, this time, ooh, okay, I'm getting there. I'm seeing it. All right. Now we need to square that and see what happens and multiply it by pi. All right. So we got 8 over pi, all of that squared, and we got to make sure we multiply that by pi. So what is so 8 squared is 64, and then we got pi squared, but don't forget to multiply that by pi over 1. Let's just be cautious. Well, notice how, like, we now know there's a 64 in the answer, so we can get rid of A and B. Those are both gone. But notice all the potential misplaces we can make mistakes. We got 64 over pi, 64 over pi squared, 64 times pi. And this is just a place where I want to slow down and exercise some caution, because I know the test writers are going to assume I'm going to make the mistake that just happened, right? I've made that exact same mistake. Whoop, 64 times pi, 64 divided by pi. So here, pi over pi squared gives me a 1 on top and a pi down below, so I'm left with 64 over pi, which is which answer, C, D, or E? Cool. All right, well done. Sweet. All right, so you now can do difficult things very quickly. This is like a 19-minute problem for anybody else, and more people get it wrong than get it right. Actually, one of these kind of questions, I love the statistics on questions like this, like, why is it not D? Because it's 64 over pi squared, and then I have to multiply that by pi. Remember, area is radius squared times pi. And so I got a pi squared here, but a pi up below, up above, Lindsay. So I got to cancel one of these pi's. That's 1 there and just a pi down below, right? So the cross cancel. Well done. All right, we'll play around. Lots of fun. Where are we? All right, so that's RDCA. So that's the beginnings of things, and this is just where things start. I'm going to actually skip forward a few pages. And so the same principles will go for, say, arcs, for anything else you want to learn. You learn a pattern, you learn to apply it, you practice it a few times, and then the really difficult problems can suddenly become so much easier. All right, so I'm going to skip forward into a particular kind of a few kind of right triangles to see again what are some patterns that we can engage that will then what are some patterns I can engage that will then save me tremendous time in the future. All right, so sorry to skip forward. All right, so let's talk about Pythagoras. Right triangles. What do you know about right triangles? What's that a good old Pythagorean theorem on right triangles? Remember the good old right triangles, good old Pythagorean theorem. What's the Pythagorean theorem? Type it in. A squared plus B squared equals C squared. All right, so the Pythagorean theorem, A squared plus B squared equals C squared, is fine. Use it. That's great. Know it, learn it, use it, memorize it, all the variations, great. However, if you can memorize a few things, you can save a tremendous amount of time. Look, the GRE is a standardized test. The GRE is a very standardized test. So what we want to do is know the things the GRE does over and over and over again. So 2 things that we want to know is, like, the GRE doesn't like long, elaborate decimals. You don't see long, elaborate decimals show up on the GRE at all. The GRE test writers like whole numbers, things like pi, things like simple square roots, right? So what we can do is, all right, what do the GRE test writers really like? Well, what they like are things that work out nicely. So anybody know the prettiest and simplest and easiest, what we call Pythagorean triplet? What are the number? Aha, 3, 4, 5. Thank you, Gracie. There we go. So we got to get them memorized, right? Because we remember them weirdly. We got 3, 4, 5, 3, 4, 9, 2, 4, 5. This is just our brains. Our brains do this all the time. Don't worry about getting it right or wrong. Just remember 3, 4, 5. Why 3, 4, 5? Well, because coincidentally, these numbers work out really pretty. 3 squared plus 4 squared equals 5 squared. because 9 plus 16 equals 25. So this being nice, easy numbers and really pretty and easy and not a lot of elaborate decimals and easy to type, this is the most common triangle that shows up on the GRE. So what you get a lot with the test writers is they take 3, 4, 5 and they hide it in really subtle, easy ways. 3, 4, 5 is a nice triangle, but what if I doubled all those numbers? What would I get? What if I multiplied all those numbers by 2? Yeah, 6, 8, 10. And lo and behold, that works also, because 6 squared plus 8 squared equals 10 squared. What if I tripled all of them? What do I get? Yeah, 9, 12, 15. That's another what we call, so these are all variants on the 3, 4, 5 triangle. 3, 4, 5, 6, 8, 10, 9, 12, 16. Multiply them all by 4, 12, 16, 25. So what I'm going to do as I look out for triangles, I'm going to go, all right, is this, first of all, a 3, 4, 5? Could it possibly be a 3, 4, 5? Chances are yes. All right. In so many ways. Is it 3, 4, 5, 6, 8, 10, 9, 12, 15, 12, 15, 25? Multiply them all by 5, you get 15, 20, 25. It's there. It's a recognizable pattern. Do I see it? The other one that shows up all over the GRE is, 5, 12, 13. So a 5, 12, 13 triangle shows up. These two, 8, 15, 17, 7, 24, 25, if you are super ambitious and you want to add those to your list, great. But I'm going to say not worth your time. Why? Because you have a calculator and they're easy to misremember. And I don't think I've seen an 8, 15, 17 triangle since 1997. Long before some of you were born. Was the last time I saw an 8, 15, 17 triangle, right? So don't sweat 8, 15, 17, 7, 24, 25, not likely to show up on the GRE. So 3, 4, 5, 6, 8, 10, 5, 12, 13. So the two most common triangles are 3, 4, 5, and the second most common triangle is a 5, 12, 13. So when I see a right triangle on the GRE, I'm going to think, thank you for, Wallace, thank you for being my age. All right. 3, 4, 5, 5, 12, 13. When I see a right triangle in GRE, I'm going to go, hey, which one are you? Which triangle are you? So are you one of these two? Or maybe, are you a different one altogether? All right. So the third most common right triangle that pops up on the GRE is what we call a 45, 45, 90 triangle, also known as an isosceles right triangle. All right, so 3, 4, 5 right triangles, 5, 12, 13 right triangles. And this is the one where square root signs begin to pop up. And don't freak out so much, because if you can just memorize the pattern, you should be okay. Now, where 45, 45, 90 triangles hide out more often than not is inside squares. The test writers love to put them in squares and make you worry about finding them, but they're always in squares. There we go. All right. So 5, 5. So there's our right triangle. There's our 90 degree. And notice half of 90 is 45 and half of 90 is 45. So that's why this is hanging out inside that triangle. Also, what makes it isosceles? Two sides are equal. All right. Now tell me about this hypotenuse, this diagonal here. Is this longer or shorter than the other sides? This is a dumb question that's very important. That other side, does it look longer? Or, all right, looks longer. And it ends up being, if I do the math out, and if you want me to, I can, it ends up being 5, not quite doubled, but 5 times the square root of 2, 1.5 times the other side. And we can work this out, by the way, of 5 squared plus 5 squared equals c squared. 25 plus 25 equals c squared. So c squared equals 50. If I square root both sides, the square root of 50 is the square root of 2 times 25. Square root of 25 is 5, and I get 5 root 2. Do you want to do that again? Because I certainly don't. Screw it. Let's memorize some stuff, okay? All right. So 5 times almost 1.5, also known as the square root of 2. Oh, by the way, square root of 2, about 1.4 something-ish, one of those irrational numbers. Anyone know the square root of 3 approximately? Yeah, 1.7-ish. If you want to memorize these approximations, Valentine's Day and St. Patrick's Day. Valentine's Day is February 14th. St. Patrick's Day is March 17th. So those are cute little mnemonic devices to remember what they are. But there we go. All right, so 5 root 2. So 7. Oh, if you want to shorten this, just say root 2. So for chat window, say 5RT2 for chatting. So 7, what's the hypotenuse? Cool. 7 root 2. 9 what? 9 root 2. Sweet. Okay. Same proportions. It's like multiplying everything by 7 or multiplying everything by 9. All right. So we're just going to call this x root 2, and that's a thing to memorize, and you can save all this garbage and not have to do that. Cool. All right. Now, that is on the level of things. I'll say if I was going to give this a GRE score, I'd give this about a 155. What I'm about to do is like a 168 level exercise. So good to know, really good for the brain exercise, but maybe a moment of heavy lifting. So it'll be okay. What if I said this was 8? Is the other side longer or shorter? Shorter. So if the diagonal is 8, the other side, think about what we did with those funny circles where the diameter, where the circumference was a whole number. What do you think the side is? Jen, you're absolutely right, by the way. Jen is right, but what's another way of doing it? So last one was divided by pi. What do you think this side is? Think about this, x times the root of 2. Ah, beautiful, Lindsay. So 8 divided by the square root of 2, also known as 8 divided by the square root of 2. All right, well done, Lindsay. All right, smiley faces, everybody give Lindsay a smiley face. We're gonna come back to what Jen did, because Jen is 100% right, and I'm pleasantly surprised. All right, I love that. Cool. All right, so here we go. So smiley face, another round of smiley faces, if you kind of see where we got and how that relates to the other thing we did. Right? Okay, so 5 times the square root of 2, 8 divided by the square root of 2. Now, there's some advanced level math that I'm about to do just to show you a thing. All right, rationalizing exponents on the bottoms of things. Here we go. So 8 divided by the square root of 2 is also, if we want to rationalize that, get rid of the root 2 on the bottom. This is something you learn to do in class, by the way. Multiply top and bottom by root 2 over root 2, and I get 8 root 2 times root 2 is root 4, which is 2. Cancel the 8 over the 2, and I get 4 root 2 simplified. All right, so also known as 4 root 2. Yay, Jen. Half as much times the square root of 2. This is something I don't have the time to go through how all that works. This is called rationalizing, but it's a cool little move. But let's save some time and memorize some things. If this diagonal is a nice whole number like 6, like Jen did, we can now skip ahead to just, let's make that half as much times the square root of 2. Cool. What if this is 10? What's the side length? Let's say half as much times the square root of 2. It's 5 root 2. Sweet. All right, you can do all the math to get there, but let's just memorize the damn thing. Why is it half as much? Because that side is longer or shorter? Shorter. All right, cool, shorter. All right, cool. All right. Cool. All right, so is it just if there's a root 2 on the diagonal? This is if there's a whole number on the diagonal. Now I can actually start playing around with some interesting fun stuff. All right, so if that's a D, what I would write down is D root 2 over 2. or d root 2 over 2. All right. So d for diagonal, and then d root 2 over 2. So flashcard, x root 2, and also flashcard, d, and d root 2 over 2, d root 2 over 2. All right. Then if I want to start playing with this a little bit more, I can start taking this side and squaring it and saying what the area is. I'm going to cut ahead of all that just to show you some fun things. But if I want to say, all right, d root 2 over 2 squared. All right, let's actually do it. D root 2 over 2 squared. So I square that d, I get d squared. I square that root 2, I get 2. I square that 2, I get 4. All right, so I square everything inside there. So this is to get that area there. And what I get ultimately is d squared over 2. Okay, well, isn't that interesting? We have a new formula for area. What's your old formula for area? How do you get the area of a square? Length times width, base times height, or side what? Side squared. Nice. So we've learned that area is side squared or length squared or edge squared, but now we've learned a new thing. We have a new formula that I would jot down. Area is also now and forever, area is now diagonal of the square squared divided by 2. All sorts of interesting ways of working that out. There's like 19, 20 different paths of working that out, but hey, how cool is that? All right, so let's run through each of these. Go all the way to the left here. That square with the diagonal of 8, what's the area? Square that diagonal, divide it by 2. All right, 32, sweet. What's the area of the next squared? The diagonal is 6, what's the area? $18, beautiful. If the diagonal is 10, what's the area? Okay, 50, cool, and cool. All right, there we go. So now, again, something that's taking everyone else 5 minutes is taking you nothing. So if you want, let me just go to the next page. I'm gonna clear some of this out. I'm gonna duplicate some of this work on the next page for you, just so that you have some clean stuff to work off of here. So let me clean this off and go to the next page. Here we go. All right, so I'm gonna flashcard something, take a screenshot, whatever, save a screenshot, do what you need to do. Here we go. So I know that diagonal is, basically that side times just squared. Oh, sorry, shoot, I screwed that up already. All right, that diagonal is side times the square root of 2. Just a little bit longer than that side, 1.4 times that side. I now know that side is d root 2 divided by 2, half the diagonal times root 2. So diagonal is side times root 2, side is d root 2 over 2. All right, just two things I have locked in my head. Area, we all know from high school, area is side squared. What you just learned today is area is d squared divided by 2. All right, you now have a flashcard. The left side's on the front, the right side is on the back. All right, smiley faces if you've got it captured. This is very good, Lindsay. Only 4 squares. Only 4 45, 45, 90. Only, thank you. Yes. Don't apply cool stuff to other things that it doesn't apply to. Thank you. Very happy. All right. So yeah, quick screenshot. All right. To get the area of a square, side squared. To get the area from the diagonal, if the diagonal happens to be 12, all I need to do to get the area of that super lightning fast without all the mathematical formula is I just need to go 12 squared divided by 2, which is basically 144 over 2, which is also known as 72. Oh. So side squared, d squared over 2. Good on that, Wallace? Side I squared has to be the longest side. Well, okay. I mean, on a square, what do you know about all 4 sides? They're all equal. So this is only on squares, all right? Yeah, so also diagonal is always, yeah, the diagonal or the hypotenuse. You could say h squared over 2 if you want as well. Okay, there we go. All right, so what do I want to do? I'm going to go forward. So we have learned so far 3, 4, 5 right triangles. We've also learned 5, 12, 13 to keep an eye out for those. And we've also learned 45, 45, 90, which is like the angles. But then we know the sides of those are x, x, x root 2. Or if I want to put it differently, x, or sorry, d for hypotenuse, and d root 2 over 2, d root 2 over 2. All right, so we've got that memorized. We got that locked. We don't have it memorized yet. You will have it memorized if you hit it every day for a little bit. So what I'm going to do, there's a couple more triangles I would keep an eye out for. For future reference, I would also work out a couple more different triangles. One that I would absolutely work out is known as a 30, 60, 90 triangle. And from here, again, I can start to get areas of things. You know what? I have time. We're going to do it. Areas of equilateral triangles. By the way, what is the formula for just flat out area of any triangle ever? How do you get the area of a triangle? All right, so 1/2 base times height. Okay. How many sides does this triangle have? 3. Okay. Just keep that in mind. 3 equal sides. This is a mnemonic thing a little bit later. How many equal sides did that square have? Yeah, 4 equal sides, or 2 that isosceles triangles have 2 equal sides. This one has 3 equal sides, 2 equal sides, 3 equal sides. There's a slight mnemonic that we're going on with here, but I just want to play around. All right, so let's, we know the base of this is already what? We're pretty clear on the base. All right, so the base is 10. Let's drop that in there. The only question I have is, what the hell is this height? Is that height 10 or not? Is it bigger than 10 or less than 10? All right, cool. It's less than 10. All right. It's tough to see, folks, but think about what's the longest side of any triangle. Jenna, if you don't see it right, it's just like measuring distances and stuff. Takes a little bit of time to work with. But what's the longest side of any right triangle? The hypotenuse is the biggest side. So Jenna, that might help you. Like hypotenuse across from that 90-degree angle, that's your biggest side. So thinking about this as, I'm going to call this the small side, and I'm going to call this the medium side, and I'm going to call this the big side. Small, medium, big. To get that base, tell me about this small side. What's half of 10? Oh, sorry, let me actually talk about what I'm focusing on here. What I'm going to focus on here is just this triangle in here, right, from here to here. Right? So to get that shortest of shortest side, what is the shortest side of that yellow triangle? Yeah, all right, we can see that because how do you get that? Yeah, it's half of 10, easy. All right, so notice this medium side is a bit longer than 5, but it's not quite twice as big as 5. If we do Pythagoras, 5 squared plus b squared equals 10 squared. If you do all Pythagoras, 20 minutes later, you will end up with 5 times the square root of 3. All right, thank you, Omkar. All right, so 5 times root 3. Knowing that, that height is 5 root 3. Do the work for me. What's half of 10 times 5 root 3? Yeah, okay, so 25 root 3. We now can get the area of right triangles. And by the way, mnemonic, 2 equal sides, you get a root 2. 3 equal sides, you get a root 3. Yeah, all right. Yeah, so the height's always kind of a square root of 3 thing. Right? So let's do another one. 8, 8, 8. Let's chop it in half. Tell me about the small side. Yes, Lindsay, this is a pattern we're going to just start locking in. So the small side's 4. What's the height? 4 root 3. Great. Ta-da. So 4 root 3, 8. And then we can just do this over and over and over again. Let's go to the next page and I'll start playing around. And so this is just a little pattern I have locked in. So do me a favor, as I'm moving to the next page, go ahead and draw like 4 equilateral triangles on your page. We're only going to do 4 of them because I think you'll have it locked. Not that, I think you'll totally have it locked by then. All right, so let's do it. Here we go. So we got 4 equilateral triangles. We got 4, 4, and 4. All right, so what's the tiny side? 2. What's the height? 2 root 3. Sweet. Okay, you got that locked. Bam. Everyone else is taking 5 minutes. You're taking 30 seconds. Yes. Awesome. All right, let's do 1/2 base times height. What's the area of this? What's the area of the whole, not the little triangle, what's the area of the whole equilateral triangle? What is the area of the whole equilateral triangle? Okay, all right, so everyone type in the, all right, so notice we got 4 root 3, I've seen 8 root 3, I've seen 2 root 3, I've got 2 root 8, I got 4 root 3. All right, I got all sorts of different things coming in. Let's play around. What is the base of the whole equilateral triangle? All right, cool. So we're not using a little bit, we're getting the base of the whole kit and caboodle. So the base of the whole damn thing is 4. What's the height of the whole thing? All right, so 2 root 3. Okay, cool. Right, so half of 4 is 2. 2 times 2, multiply the stuff on the outside, is 4 root 3. So well done, but lots of mistakes. It's easy for things to happen. So I'm going to say this is an equilateral triangle that's 6, 6, 6. Fill in the missing pieces and then get the area of the whole thing for me. What do you get? Try one more time. So you copy it down, you fill in the missing pieces, you do 1/2 base times height. What do you end up with? Nice, well done. Okay, so little side 3, height 3 root 3, and then you go half of the whole base times 3 root 3, and you'll get half of 6 is 3, 3 times 3 root 3 is 9 root 3. So the area, now you can get area of equilateral triangles. How awesome are you? All right. Again, I just want you to carry this principle forward. You learn a thing. Oh, that's cool. I practice it enough time to get it totally locked in my head so that all the things that took me 10 minutes the first time I did it take me 30 seconds because I know the pattern. That's anything that shows up on the GRE as much as I can. People are like, how do I get faster? This is how you get faster. No, we're getting the area. That's the base of what? The right triangle or the whole equilateral triangle? That's the base of which one? This is a area, that's the base of what part? The whole thing. All right, so cool. So this is the area of the whole equilateral triangle. Okay, all right, so it's the whole. So if I'm doing 1/2 base times height, so I'm gonna get, yeah. All right, so let's actually show you some real ones. Let's go. All right, so we got a couple minutes to, Jenna, yeah, we can actually think about it. What is it? Side squared root 3 divided by 4 if you want the area of an equilateral triangle. So you can just work the formula here. But as far as understanding, I just want to make sure you got the understanding thing as well. Yeah, so if you want to get the whole formula of an equilateral triangle, side squared root 3 divided by 4. Okay. Yeah, so if you want to jot that down, cool enough. Let's go to the next thing. All right, so what we're going to do here is we're going to just start seeing how things get answered or how questions get asked on the GRE. So let's begin. All right, so let's put some stuff. All right, so my question running into right triangles is which one are you? So we got 3, 4, 5, 5, 12, 13, 45, 45, 90, 30, 60, 90. Which one is this? Yeah, 5, 12, 13. All right, great. So this will be, okay. So this is 5, 12, 13, 1/2 times 12 times 5. And so the area is what totally? All right, 78. So Leda, does this fit the pattern of a 3, 4, 5? Not quite, because this isn't anything times 5. So it's something, something, something. All right. So, but is it a 3, 4, 5? Is it a 5, 12, 13? Is it a 30, 60, 90? What is it? And you can start, yeah. So rather than dealing Pythagoras, we've just got some stuff memorized. So let's go to the next one here. I love, we're working in Zoom now for the first time. So yeah, so 30 is our ultimate thing. All right, so Zoom is way better than our previous system, but old things we write stay. Okay, so if I look at this next one here, this one, Pythagoras, I will let you know is a freaking nightmare, right? I don't know, 78, not so much. 30 is our right. 30 is it was our final answer. So 1/2 times 12 times 5, half of 12 is 6, 6 times 5 is 30. So that was our last one. All right. If on this one that's on this page right now, I wanted to do Pythagoras, I would have to do x plus 2 squared plus x minus 1 squared equals x plus 5 squared. On a scale of 1 to 10, how much do you want to do this? All right, cool, -1,000. All right, no, bad. All right, sure, good exercise, but I don't have the time to mess with this on the GRE. I have no time to deal with this on the GRE. So I'm going, hey, which one are you? Are you a 3, 4, 5? Could you be a 5, 12, 13? And also, rather than algebra, I'm given something on a GRE that I'm not given on other math tests. What am I given on this GRE question that not very few other math tests give me that you got in high school? Given a square. Well, it's not a square because the sides aren't the same. What do GRE questions give you that other questions don't give you? What do you get on the GRE that might be really, really helpful so that I can avoid algebra? Not a calculator. What am I pointing at, everybody? Emmy's got it. Lindsay's got it. Julie's got it. All right. I'm giving the damn answers. Aha. How cool is that? All right. Watch this. So what I'm going to do, if I'm given the answers and I don't feel like doing, and this, by the way, is geometry, but this is pretty much anything else on the GRE where I look at the algebra and I go, forget that, F that, no, why would I do that? So if I'm given the answers, I have a tendency to start with C to see whether I need to go higher or lower. Right, so I don't have to go through all 5. I'm going to start in the middle and see whether I want to go up or down from there. So let's see with C what happens. So if x plus 2 equals 12, because they asked AC, what does that make x? So X is now 10. All right, so what does that make side AB? So that's 9. All right, so I'm just saying, hey, could 12 work? And then what is X plus 5? That's 15. Is that a thing? Aha, Shanna spotted it. Excellent. Notice 9 is 3 times 3, and 12 is 4 times 3, and 15 is 5 times 3. Is 9, 12, 15 a thing? Yes or no? Yes, it is. It's a 3, 4, 5 in disguise. All right. Is C going to work? Yeah, absolutely. Right. Yeah. So the difference in each side. So which one is it going to have to be? Right. So yeah, first of all, it looks kind of like GRE's 3, 4, 5. I know it's not a 45, 45, 90. I know there's no roots, so it's not a 30, 60, 90. How did I get X to be 10? Well, if X plus 2 equals 12. So I'm starting with C. So if X plus 2 equals 12, subtract 2. Does it? Let's see if B works also. So if X plus 2 equals 10, what's X? All right, X is 8. So what's X minus 1? 7. And what's X plus 5 then? 13. Is 7, 10, 13 a thing? No, it's not a thing. All right, cool. No, it's fine. It's just the way, it takes a little, it took me a little bit. I had to rock that one out twice before I taught it today because I kept mixing up what was X and which was X plus 2. So yeah, so 10's not a thing. You run through the rest of them. They're not a thing. The only one that works out to be a nice 3, 4, 5 is 9, 12, 15. Ta-da. Yeah, again, the advantage of starting with C is I can tell. This one, not so much, but I can tell whether to go up or down. Yeah, I start out with C because it's in the middle on these because that'll tell me whether I need to go higher or lower. And also, hey, in this case, it turned out to be the answer. Wasn't that nice? Just mostly when I'm doing this on more algebra questions, if I get something too small, I can go higher. If I get something too big, I can go lower. Yeah. Well done. All right. So that shows me, again, recognizing and spotting patterns. So I'm going to do one more just because you're awesome and I'm having fun. So you get a little extra free time from Uncle Neil. Other than that, we will... No, they're like, no, Saba a little bit. Yeah, I'll show you one. No, C is the answer. Remember, C was a thing. B was not a thing. They wanted to know what was the length. We started with C, right? So C was the thing. So anyway, yeah. So they're not asking for X. They're asking for what AC was. Yeah. All right, let me go back. Why was C the answer? They said, did they asking what is X or what is AC? What's the question? Jenna? All right, yeah. So the question is the length of AC. All right. So we started with answer choice C. Sorry. Things keep advancing accidentally on me. So we started with a length of AC, not with, all right, so we said AC equals 12, and that made X equal to 10, right? And so X was 10, but the answer was 12. So that helps out. So there's some confusion of what the damn question is asking. We call this the principle of RTFQ, which stands for read the question. There you go. All right. All right. There we go, folks. So again, do I want to deal with algebra? No, I just want to jam the answers and play around. And also, hey, which one are you? Oh, you're a 3, 4, 5. I can see that. Could you be a 6, 8, 10? Could you be a 5, 9, 12, 15? There we go. All right. So let's go forward. I just want to show you all the principles together and show you I'm going to model one for you just to show you like how quick it can be. All right. So this is kind of a GRE question. You get this figure and they say the area of the circle is 64 pi. What is the area of this inscribed square? So what I know is it's a circle. What do I write down? All right, RDCA, radical. All right, so here we go. So the area is 64 pi. That means the radius is 8, diameter is 16, circumference is 16 pi. Great, okay. So I just do that because, all right. Based on all of that information, what part of the square can I figure out? By the way, should be touching. These are all inscribed means it's touching on all the sides. So what can I figure? I can figure out the diagonal of the square, which is what part of the circle? It's the diameter of the circle, diagonal of the square. Coincidence? I think not. All right, so I know that diagonal is 16. So I have a square with diagonal 16. What was my formula I had you write down for getting the area of a square from the diagonal? You might not have it memorized yet, but flip back a page. All right. So d squared divided by 2. All right. So this would be 8 root 2 as a side, if you know that. Those are the sides. But the question is, what's the area of the square? And I can jump right to the formula. So 16 squared divided by 2. What's 16 squared? Not the square root of 16, 16 squared there, Jen. No, don't apologize. Welcome to our brains. Like, this is just the wonderful world of the GRE. As the GRE test writers know that we mix up squaring and square rooting all the time, that we double instead of squaring, we square instead of double. This is just what happens to our brains. So we just want to be aware of when those mistakes happen and just practice so we're not making those mistakes anymore. All right, so 256 divided by 2. And again, that's 125 plus 3, also known as 128. And we're done. All right, so the area of inscribed square is 128, and we're finished. All right, this is a nightmare question for anybody else but you now. All right, welcome. That's my having a really fun time with geometry. So we learn a thing, we learn another thing, we put the two things together, you learn some formulas, you can save a boatload of time. Okay, I need to wrap up. And I really enjoyed working with you all, so I'd love to see you again sometime soon. So here we go. I'm going to flip all the way to the end of things. This is everything I ever teach forever. All right, so if you want an overview on the GRE, again, I highly recommend you show up to class 1 of any one of our classes. So you get to Lindsay, check out YouTube, the Manhattan Prep site on YouTube. There's lots of cool stuff of specific areas. But other than that, there's lots of cool stuff that's out there. Other than that, if you want more, class 1 is an overview of the GRE overall and just an introduction to our classes. So manhattanprep.com/GRE/classes. There's Interact, there's video lessons online. By the way, Lindsay, that's the paywall version of things. That can help you with specific areas. Other than that, I would totally recommend just learning something in Remove Book, doing the massive chapter in the 5-pound book until it's locked in and you can do everything super quick. So check out all of what we have on manhattanprep.com/GRE, and that's there. Other than that, I have a class actually starting a full 8-week class starting, it's coming up, by the way. It's starting November 29th. Is my coming up very soon. So Thursday, November 29th, and the class is, if you want to dig it up, it is Fall Q is the, it's live online. Fall Q is the one I'm teaching. So, I will do similar things, overview of the GRE, some specific tips, but other than that, you were awesome, and Yeah, I understand, Lindsay. Class 1 is free. The whole 8-week class is not free. The whole 8-week class, you check the pricing online. But go to manhattanprep.com/GRE/classes. Look for Fall Q. That's the online one starting this November. But there's classes starting all over time and all different times all over the world. So, well, thank you for your compliment. But otherwise, people watching online, check us out online. We'll catch you very soon. Bye. Take care. Have a great day. All right, folks. Any last questions? I'm going to shut down the room here in a moment and definitely going to stop recording.